All right, today we're going to talk about vectors and applications. So a vector is a mathematical quantity that talks about direction and magnitude. If you want more, watch Despicable Me, the first one. Vector talks about it. So a vector is kind of looking at directional capability. So when we're looking here, here's a vector here, AB. And what happens is we have a starting point A and a terminal point B. And it has a length or a magnitude on that. And to find that magnitude, what we're going to do is we're going to actually use Pythagorean's theorem. So we're going to find the pieces here, the left and right and the up and down, and square it, just like we've done before. So here's we're finding the magnitude of vector u here. So I have a starting point of 2, 4, and then I have a terminal point of -1, 3. And what we're going to do is we're going to look at this in Pythagorean's theorem, and we're going to kind of create that triangle, because what's happening here is we're going down and over. And so we're going to use that to find our magnitude. So I got 2 minus a -1 quantity squared plus 4 minus 3 quantity squared. So this becomes the square root of 3 squared plus 1 squared, which is the square root of 10. That is our magnitude, okay? Now we're going to talk about vector addition. So if I have two vectors here, what I'm going to do is if I'm adding them, what I'm going to do is I'm going to take my vector, my second vector, and put it at the terminal point of my first vector. And what's going to happen is it doesn't matter which one you start with. If I wanted to go u, then v, I would go u and then up v. And my addition is the diagonal. So what happens here is you're actually creating a parallelogram with v on each side and u on each side. Okay? So if you're in physics, you've probably done this. And the sum of those vectors is that diagonal. So last thing we're going to look at is we're going to look at a problem here where it gives us the magnitude. So it's the magnitudes of vector u and vector v and an angle between them. And what we want to do is we want to find the magnitude and the resultant angle that makes with the smaller force. So the first thing you want to do here is draw this out. Make sure you draw this out. So I'm going to come here. I'm going to put this is u, and I know that this is 10 units. Okay? So the main u, I'm going to take v up here. This is 67. I'm sorry. So here's this. This is 67 degrees, and this is v, and it's 12. So the magnitude of v is 12, the magnitude of u is 10 here. And I'm going to just finish off my parallelogram. So this is still 12 and this is still 10. I know my drawing is probably a little off scale. Now, when I add these together, I'm going to go from corner to corner here. And this becomes u plus v. Well, now this angle is in 67. But what we're going to do is we're going to take that and we're going to subtract it from 180 to find this angle. So this is 180 minus 67, which gives me 113. Okay, so this is an angle of 113. Now, if you remember, we worked the law of cosines, so I can find this length here. So this is like A, and this is big A right here. And so I'm going to use the law of cosines. So I have little a squared equals 10 squared plus 12 squared minus 2 times 10 times 12 cosine of 113. And I'm going to take and I'm going to plug that into my calculator here. 10 squared plus 12 squared minus 2 times 10 times 12 cosine of 113. And so this right here gives me a squared equals 337.78. And now I'm going to square root that. And so I get A is approximately equal to 18.4. So my magnitude of u plus v is 18.4. So that's my magnitude. Now, I really want to find this angle right there. Well, can I find that angle? Well, I can't. I can use the law of sines now and find that angle. So sine theta over, and my opposite side here is 12, equals sine of 113 over 18.4. And so I'm going to cross multiply here. I'm going to multiply it by my 12. So sine theta equals 12 sine of 113 over 18.4. Plug this in my calculator. Oops, 18.4. And this gives me sine theta equals 0.6. And so I'm going to take the inverse sine of this. And I get theta. So the angle between these is 36.9 degrees. Might ask you to round to the nearest unit, so that'd be 37. So that is vectors and applications.